Hey everyone, this is Jim Armstrong with Snyk. Thanks for joining us here today. Today we're going to do a presentation about using Snyk in conjunction with Docker. And so we have a number of users who use Docker tools like Docker Desktop and Docker Hub, and those are wonderful tools for building containers and creating your containerized applications that a lot of developers use. And what we've done with Docker is we've actually integrated Snyk's security tools into Docker's container tools. And so we'll take a look at how those things work today. We'll talk about the bigger picture and how those bits of security work into the bigger picture that Snyk offers in terms of application security as a whole as well. But we'll get to see a little bit of all of those things. I'm joined here today by Anthony Cito, who is a member of our cloud native team here at Snyk. If you have any questions along the way, I would encourage you to ask those questions. You can type them into the Q&A panel, and Anthony and I will answer those as we go through the presentation today. We'll also be recording today's presentation, so if you want to see it again later, or if you want to share this with others, you can certainly do that as well. So without further ado, I will go ahead and get started here. Again, we'll do lots of demos today. A few things that I'll do up front just to sort of level set on what we've done with Docker and show you some of those things, but we'll do a lot of demos. So you'll get to see these things in action and get to see a little bit of the workflow for these tools and how they go together. We'll also show a little bit more on the Snyk side too, so you can kind of see once you've done some of the scanning and things with Docker, there may be some other things that you want to do along the lines of application security. There may be some other areas, some other places along your software pipelines that you want to integrate security, and we'll show you how Snyk can work in those situations as well, so you get sort of a full end-to-end picture of how you might be able to use Snyk. So everybody here is probably familiar with Docker. It's they've revolutionized the use of containers. They made it simple and accessible for pretty much anybody to use containers and to package up their applications in containers. One of the things that Docker users have asked for, it's always been one of the top asks. I actually worked at Docker before I joined Snyk, and one of the things that people would ask for quite frequently was additional security tools inside that Docker tool set. And so we were really proud from a Snyk standpoint to be able to integrate with Docker. For me personally, it was great because I've worked for both companies, but in general, we both have this very developer-focused mindset. So both of us are creating things that are really almost exclusively used by developers to help them build applications and ship those applications faster and make them more secure. And a lot of this security part is being moved over to developers. So as more and more of the sort of things outside the code or around the code become a developer problem, the security issues come right along with that. And so what Snyk has done, and sort of our core, our secret sauce, if you will, is making that security information available, accessible, and actionable by developers. And so we'll take a look at what that means inside of Docker and what it means for containers in particular, because containers are a weird thing to fix. They're not exactly code. There's a lot of sort of things that are in there inside a container that are not your code or your application at all, and fixing some of those things can be a challenge because of the way containers are built and maintained. So we'll take a look at how we solve that problem with Docker and Snyk. The other part of this is the fact that those things that are in a container, because they're not code, it's a different set of skills that are required for maintaining these things. In the past, when it was a virtual machine, there would be a dedicated system administrator who was very good with operating systems and would know all the ins and outs of a chosen operating system and how it worked and how they patched it and when patches would be available and where to get them and all those kinds of things. But containers obviously are very different from that. Containers could be any number of Linux distributions that might be in a container. You inherit a lot of that depending on your choice of base image for your containers. Inside of an organization, there's a lot of times there's sort of multiple steps. So somebody will be taking a base image from Docker, and then they're building kind of their internal base image that they want the application teams to use. And then the application teams are only responsible for a subset of vulnerabilities that they introduce to a container. So this whole layered nature of containers also changes things, along with the fact that these tend to be operating system packages, Linux packages. And so fixing those, number one, requires a little bit of Linux knowledge, but also requires some container knowledge, because you don't just patch a container the way you would patch a VM. So we'll take a look at how we can help with those things. As I said before, Snyk's approach to this is to be very developer first, developer friendly. So, you know, when it comes to containers, probably everybody has run a container vulnerability scan before, and there are many tools that will do a vulnerability scan for all kinds of different artifacts that you might have. But when it comes to containers in particular, making that information, instead of making it just a long list of vulnerabilities that you might have, and listing out all the libraries and individual files that might have a vulnerability in them, we want to make it simpler for a developer to fix. So getting back to sort of the top level packages that are in a container that need to be addressed, and determining whether it's part of the base image or it's part of something that you might have added in a run command in your Docker file, for instance. Those are the types of things that we want to make very easy when it comes to fixing containers. That also gets into the next point here about actionability. And again, instead of just listing out 900 vulnerabilities, we can tell you that there's a bunch that are in the base image. And if you fix the base image, you can take out a mass number of those at once, as opposed to going one by one and trying to do the research on each one individually to figure out how you might fix that particular vulnerability. Also comes into play with things like deciding what to focus on. Which are the highest priority vulnerabilities in your system, in your entire pipeline, not just in a single container, because everybody is running many containers and many different images. And so knowing what to focus on and what to fix first is also important. And of course, the base, the sort of platform on which all this stands, is the security intelligence itself. So gathering information from the various ecosystems and communities that make up the container world, that make up the Linux world, that make up the application world as well. That's a big part of what Snyk does and brings all that into the product. So as we go through this, we're going to focus, again, as I said, really focus on the Docker integrations here. We'll show a little bit of where Snyk can plug into some of these other areas. We think about in the Docker world, we talk a lot about build, ship, and run. You'll hear various things for this, so the software supply chain, or the SDLC, software development lifecycle. But Snyk can plug in a number of places. We'll focus on the Docker integrations today, but there's other places where you could use Snyk as well. The Docker integrations, as I said before, really meant to be the place where a developer would see these things. So at your desktop, as you're building and starting to create a container and put your application into a container, so that you get started in the right place, get started with a good container, seeing it in Hub. So if you're sharing a container amongst your teammates, you can see the scan results in Hub as well. Both of those are good sort of starting points, but certainly not the only place where container scans take place in general, and probably not the only place where you want to do them. So speaking of Docker Desktop, it is integrated in Docker Desktop. So if you have the latest versions of Docker Desktop, you should see it. It's in both the stable and the edge builds of Docker Desktop. You'll see this new little Snyk icon if you go to the About screen in Docker Desktop, and it's in both the Mac and the Windows versions of Docker Desktop as well. So you'll see this new little Snyk icon. That'll be your quick indication that you have it there. Of course, you'll have a new command called docker scan, which you'll see here in just a second. But that's it. That's how Snyk works. So there's nothing extra that you need to install. There's nothing else extra that you need to sort of set up. It's just built in to Docker, and that's the experience we really wanted to provide here, was making this as simple as anything else that you do in Docker. And so Again, it's just a command that's built into Docker. We'll start to get into some of the demo portions of it here, but if you go through the Docker system and the Docker command line, do a Docker help, you'll see this new command called scan. So just like you would do a Docker build or a Docker run, there's a Docker scan command, and that's the piece that does the security scanning. And how you run a scan is incredibly simple. You just type Docker scan and then your image, name and tag, and it will do the scan for you. So I'll show you that here in just a second, but that's a really simple and fast way of doing a scan. There is a little bit more information we can provide than just that simple scan though. And so what you're seeing here is a second command where instead of just doing that base scan, we actually add the Docker file to the scan. So as part of the scan, what we do there, what Snyk does, is take the information in the Docker file and provides a little bit more clarity about exactly what's in that image and where some of the vulnerabilities come in. So let's take a look at that so you can actually see this in action, because it looks a little nicer than it shows in a slide. So I've already done a scan here, and this is the first scan. So this is that simple scan. I just did Docker scan, and I have this image called Purple Dovey blog, and I have the demo tag here. So I've done this simple scan on it, and you can see the type of information that you might be familiar with in a scanning tool, any other scanning tool that you might have seen, right? So we have high, medium, and low vulnerabilities. We have a list of what's vulnerable in here. What might be a little bit different from some scans you've seen is we actually have the dependency information listed here as well, right? So here's a vulnerability that's in some library, right? This looks like a printing library, but anyway, there's a vulnerability in this library. But rather than just knowing that this is the library that's affected, because this is probably not something that I directly put into a container, it tells me how this vulnerability came to be in this container. And as it turns out, it's this thing called ImageMagick. And because I installed ImageMagick, it installed all these other libraries, and one of those libraries required this cups library. And so that's how the vulnerability got into this container. And then of course the fix information is there. Now, again, that's still relatively basic information. It is helpful a bit, but it doesn't directly get me to the fix. And so that's where that other scan comes in that I think is a little more useful and that people do more often. And that's the one that looks like this. So here, it's the exact same container image. It's really not that much different in terms of the command, except I added this my Docker file to it. And you can see the Docker file for this image. So it is a Ruby application. I'm starting with the Ruby 2.5.1 image, and you can see I've installed some additional packages into it, and then Ruby gets set up and runs in there. And so what I did is I added the Docker file to the scan here. Now, what's different about this scan is a couple of things. The first thing you'll see right here as sort of the end result, and so that's the first thing you see on screen, is that it tells us not only the number of issues, but it tells us how many of those issues come from the base image. So I have this Ruby 2.5.1 base image, and I can see that there are 923 vulnerabilities in that base image by itself. 254 of them are high severity vulnerabilities. Now, I do want to point out here, because you may be wondering why we have 915 total vulnerabilities when there's 923 in the base image. And that can happen for a number of reasons. Usually it's because something else got installed in the image, and it overwrites some of the things that are in the base image, and so they get fixed. So essentially, I fixed 8 issues by something else that got installed into this, but I still have 915. By no means is this a ready-to-go image, I would say. So what we do is we provide a little bit more information beyond that and provide recommendations on ways we might address the base image and create a better, or use a better base image and build upon that. That tends to be the biggest bang for your buck. It's the fastest way to kind of address a bunch of vulnerabilities fairly quickly, as opposed to rooting through and trying to address some of the other vulnerabilities one by one. And so if we can pick a better base image, we can probably get to something that's much more secure much quickly. And so what we've done is we provide these base image upgrade suggestions. And so if we go to the Ruby 2.5 image, we'll get down to 300 vulnerabilities, and only 39 of those are high severity. Or there's some alternatives here where you can go to Slim images and get those down even further. The difference between some of these levels of vulnerabilities is that a minor upgrade like a Ruby 2.5 is still the same version of Ruby. We're still in this 2.5 family. And so it's going to match up with that, but it's also still a fairly big image. This Ruby 2.5.1 image is, it's got loads of things packed into it. When you look at base images that are out there on Docker Hub, these are all Docker official images, right? When you look at those, there tend to be some that are fairly big images. Those are really good for getting started because they'll support a wide range of use cases. But as you start to develop and want to run these containers, particularly as they get towards something that you want to run in production, these tend to have way more things in them than you really need for your application. And one of the sort of best practices with a container is you only want to have things in the container that your application really needs. And so if you're starting with these really big images, you're going to end up with a bunch of extra stuff. From a security perspective, that's where it starts to light up all these alarms, right? That we have way too many vulnerabilities in here. And most of these things are probably things that you don't need. So if we stay with those fairly thick images, we can do better, get this Ruby 2.5 image. It's a newer image. It's been maintained a little bit better, so it has a bunch of fixes in it. But if I go to the Slim image, I get rid of all that extra stuff, right? And so that's where we see this huge drop in vulnerabilities from 923 down to 58, because we got rid of a bunch of stuff in it. When I say we, I really mean Docker and the Docker image maintainers. Got rid of a bunch of stuff that's in that base image. And so there's far fewer vulnerabilities. Now, that might mean there's a little bit of extra work for me as a developer, because I'm probably going to have to add some things back in to the image. And with Ruby, it would be some development libraries so that my gems will build. If you're using other languages, you would have a very similar sort of process. But those things are easy to figure out. And because you're adding those things in explicitly, you know exactly what's in the container. If there's something wrong with one of those things, you know exactly what to do to fix it. So there's a lot of advantages to getting down to these slimmer images, aside from just making them more secure. Anyway, that's all there. So that's a nice view. That's one thing you get by adding the Docker file. The other thing you get, if you look at the vulnerabilities themselves, it tells you which ones were introduced in the base image. And if we scroll up here, I can probably find one where it tells me this one was introduced by this run command that was in my Docker file. So that's another bit of information that you'll get when you add that Docker file in, as we'll tell you, exactly where this was produced. So we have the dependency information here and how it got introduced, but we also have the actual place in the Docker file where it got introduced. So as a developer, that helps me fix it as well. One other thing you might notice that I added here is this dependency tree. So we talked about the fact that with a vulnerability, I can kind of see the dependencies and how this got introduced. But this dependency tree also allows me to print out the dependency tree for this container. These are not just vulnerable dependencies, these are all the dependencies inside the container. So all of the tools and packages that we found inside the container and the various versions that are in there. So if you want to know what's inside your container, this is a helpful command for seeing that, whether it has a vulnerability or not. And as you can see, this is one of those big sort of fat images. Again, it's good for a wide range of use cases. It's probably not great from a security perspective because it does have so many different things in here, and probably we don't need all of those for this particular application to run. But anyway, helpful information there that you can get. Again, that's all available through these Docker scan commands, and that's all built in to Docker Desktop. A couple of notes on this with the Docker scan commands. Everything that you saw there is free. So if you get Docker Desktop, you can run those commands and scan your container images with Docker Desktop. The only caveat there is you get 10 free if you don't log in. If you do log in, which will effectively create a Snyk account so that you link up your Docker Desktop to Snyk. If you don't do that, you get 10 free scans per month. But once you do that login, and it's really simple. I'll show you here. So there is this login command, docker scan login. Once you do that, and you can use your Docker ID. So if you have Docker Hub ID, you can use that to log into Snyk as well. But once you do that, you'll get 200 scans per month. So you get this big increase from 10 scans to 200 just by doing that login. Then with a Snyk account, you can do more as well. So Docker Desktop is really focused on that sort of desktop use case. As an individual developer, I want to scan things as I'm creating them, just so I know what's going on and I get started in the right way. If you want to do scans in CI/CD, for instance, you can do that with Snyk. You wouldn't do that with Docker Desktop today. You would do that with Snyk, and Snyk can integrate with just about any CI/CD you have, including, if you use GitHub and you use GitHub Actions, you can do that as well. But you would use Snyk for that. And this Snyk account that you've got, which again is free, there's no cost to this to get started, would allow you to do that and set up the Snyk CLI. Really, it's pretty much the same type of options that you have there. So there's not much difference in the output from the Docker scan command versus the Snyk CLI command. Obviously, the Snyk CLI command can do other things aside from container scanning. So if you wanted to scan your code itself, particularly the open source dependencies, you can do that with the Snyk CLI too, and you can also monitor things. So when you're looking at Docker Desktop, we're doing a scan of an image. That's what it looks like right now with the current vulnerability database today. Tomorrow, there could be a new vulnerability. So if you want to monitor your images and get alerts when there's new vulnerabilities, well, that's where that Snyk account will help you as well. You can monitor an image, in which case it gets sent to Snyk, and you can kind of see the screen here. If there's a new vulnerability tomorrow, I can get an alert on that that'll tell me there's a new high-risk vulnerability for my blog image, and I can go and take a look at that and fix it from there. All right. So we talked about this ability to monitor. I'll show you a little bit more detail about what that looks like. So once you've started this sort of process of doing the basic scans with Docker Desktop, you can actually monitor them. You'll get, again, very similar information. I'll show you what it looks like in the Snyk UI so that you can see that there. But it's very similar information. There's some nice ways of going about filtering those things in the Snyk UI. You can use if you decide to continue on with Snyk and you become a paying customer, you can use the API, and there's lots of advanced things you can do. At that point too, you can plug it into your Kubernetes clusters and do scans there as well. But I'll show you these two things. So let's take a look at within the Snyk UI. So here is the same image. Let's go to well, I'll use this one. They're all about the same. So here's that purple Adobe blog image again. You see same sort of thing. Tons of vulnerabilities here. This one's set up for monitoring. So you can see it was tested 16 hours ago. By default, it's going to be tested once every day. So if there are new vulnerabilities, those are going to appear here. The other thing I get, because this is inside of the Snyk interface, within the container, it's also finding all the various kind of dependency files that are in there. So if it's a Ruby application, so of course it's finding my gem files. There's a little bit of Node and other things kind of set up in there, so it's finding those dependencies as well. But it's also telling me when I have vulnerable packages in my application as well, and those are being monitored for new vulnerabilities too. So that's a nice thing I get by setting up that monitoring within Snyk. If I actually go to the image, you can see here, again, like I said, it's very similar information. It's a Ruby 2.5.1 image. I've got several options in terms of changing that image, upgrading to slimmer images and images with fewer vulnerabilities. And then I also have all the details here about the vulnerabilities, just shown in a slightly different way. Some extra bits of information that are slightly more obvious, I think, in this view than in the CLI view. We can filter things out here very quickly and easily. So if I want to just focus on the high severity vulnerabilities, I can. If I want to look at just vulnerabilities that have a mature exploit for them, I can do that as well. So here I've got high vulnerabilities with just a mature exploit. The other thing you'll see is this little score over here. This is our priority score. This is not currently viewable in the CLI, but you would see this in Snyk. This combines several different vectors. So in this case, we have a high severity vulnerability that has a mature exploit. And so that gives us a certain priority score. If this was running in a Kubernetes cluster, that would bump up the priority as well. If it, if the Kubernetes pod itself was set up such that this was running as a privileged container, that would bump up the priority, right? So several different factors that can go into this priority score. That helps us when we're looking at something like, 1,000 vulnerabilities, which we have in this case, right? It helps us focus on the ones that are the most important, right? Which are the ones that I want to take care of first. And I can take out all the base image vulnerabilities as well. In fact, I can do that on the command line side as well. It really is not much of a different command. I would just do this exclude base as an option, and that'll take out all the base image vulnerabilities. So if you have a process internally, and this is very common, where there's a team that kind of maintains a set of internal base images. So that team is going out to Docker, they're creating the internal base images. They're going to be interested in, in this information, right? I want to get to this Ruby 2.5 Slim for my internal base images. But then as the application team, that's not something you have to worry about anymore because that other team is doing it. So in that case, the vulnerabilities that appear in the base images are somebody else's responsibility. And so you have this ability to do this exclude base from the command line, which you can do with the Docker scan command, or you can do with the Snyk CLI. And you can also get to pretty much the same view in the Snyk interface by selecting I only want to see things that have the user instructions. And again, you can see that user instruction in here as well. A couple other things you'll see here that are kind of important to think about as you're dealing with this. In the vulnerability information, right, we see high, medium, and low. Snyk is handling all that for you. So what makes it high, medium, and low? Obviously, it's related to the vulnerability score itself, but we do take into account things like the individual distros and what they say about that particular vulnerability. So in this particular case with this vulnerability, this is a Debian-based image. The base vulnerability score is critical. Debian hasn't done anything or said anything that would change that score, and so we've kept it rated high in Snyk. We use high, medium, and low. But there are other cases where, I'll show you one of those, where here, for instance, there's a vulnerability that the base vulnerability in and of itself was rated a high severity, but Debian, the maintainers of Debian, have looked at this in relation to how they maintain the Debian OS and they maintain these particular sets of packages. They've said that this one is actually unimportant if you're using Debian, or which we relate back to a low severity, right? So that's reflected in here as well. What you would see in the Docker scan command is you just see low severity. If you want to get into the details, you can, and there's when you're doing these scans, if you want those types of details, you can do JSON output and it will give you all the details. And of course, it's in JSON format, so you can do all kinds of filtering and other things with it as well. Okay, let's go back here. Before I keep rambling on, Anthony, are there any questions we should bring up now?
There are currently no questions in the chat. If you do have any questions, feel free to put them in the Q&A panel and we'll make sure to get them addressed.
Okay, great, thanks. So a couple other places that people like to scan for images. One really popular place is in their container registry. And there's a couple of ways you can tackle this when you have Docker and Snyk. The first one that I'll show you here is by turning on scanning directly within Docker Hub. So Docker Hub today now has a vulnerability scanning feature that's built in. Now, this is available to pro and team accounts. It's not available on free Hub accounts, but if you have a pro or a team account in Hub, you have vulnerability scanning available today. You just have to enable it. Then you can enable it or disable it on a per repo basis as you feel it you feel you need it. But again, that's using the same Snyk technology, and there's really, again, nothing extra or special that you need to do to set it up. You just need to enable it, and then when you push an image to Hub, that image will get scanned. You'll have the same, it's the same scanner. You'll get the same vulnerability results. You don't get quite the same level of sort of detail. So if you want to see the base image information and you want to see some of the fix advice and those sorts of things, that's something you're going to do with the Docker desktop tool or with the Snyk CLI. But this will give you a good view of whether that image as a whole is kind of a safe one or not. As you're sharing it with other team members or somebody else has shared an image with you, this will give you a good view as to whether or not this is something you really want to use, or maybe it's something that you want to fix. I can show you that here real quick. It's a pretty simple thing to enable. Oh, shoot. Get logged in here. Okay, so I've got an organization called Purple Adobe here, and we've got a number of repositories set up. I'm going to use this blog repository. I think. Oh, I see what I've done. Okay, there we go. Took me a while. Okay, so we've got vulnerability scanning here by Snyk. I can enable it or disable it. This is, again, if you have a pro or team account, this will just automatically be there. There's nothing special that you need to do for that. I have it enabled here. And anytime I push an image to this repository, just a simple Docker push, this will automatically scan it for me. So we can see those images here. If I go into the actual image itself, there's a new vulnerabilities tab that will appear, and it will show me all the individual vulnerability details. Again, if you want to dig into some of the dependency information, that's here as well. If there is a fix available, that shows up here too. But again, this is really meant to be kind of that high-level view of, is this image something that's good or bad that I really want to use or not. If I get to the point where I decide this is something that I want to fix and I want to take care of, I would do that probably at the local desktop. I would use the Docker desktop scan and figure out, what can I fix in the base image versus what's in other parts, or I would use the Snyk monitoring and the Snyk interface and do that same sort of task of tackling it there. But this gives me that good interface to kind of, again, share it with teams and see what's happening in Hub. Now, as I said, there's another way we can go about this, and that's to integrate with Hub from the Snyk side. The difference there is one is directly in Hub. If I log into Hub, I see the scan results there. The other is going to show me the results in Snyk. And so that's essentially what's here, and it's what we looked at before. So when we were looking at this blog image, you see the little Moby icon here. This is actually integrated with Hub. So I have Snyk integrated to talk to Hub and to look at images that are in Hub, and it pulls those results into Snyk for monitoring longer term. Again, the biggest probably advantage and difference here is that I have all the application vulnerabilities as well as the container vulnerabilities because I've done it this way, and we have the continuous monitoring and alerts, and everything is centralized from a security standpoint, whereas Hub is going to centralize everything from an image standpoint. So just a slightly different way of looking at things. You can really do either one with the products. or you can do both actually as well. So some other things we talked about here as well, right? Other places that people tend to want to scan for vulnerabilities. Obviously, scanning at your desktop is great if you're trying to get off on the right foot and get going and make sure that the containers that you're using are appropriate and secure. But that's probably not the last place where you would scan. Most people are to the point where they're automating all of this. They have automated or at least semi-automated deployments, and most of the testing that they want to have done in sort of an official standpoint to check the boxes is being done as part of that automated process. So you'll have various CI tools, and we can really work with any CI tool. This happens to be a screenshot from Circle CI, but you can use just about any CI tool if you want. Again, as you see here, while this is all built into Circle CI, it really works very much the same. And so we've got here, what we've done is I've filtered to just the medium severity vulnerabilities and above. I've linked up the Docker file just like we looked at before. I've excluded the base image vulnerabilities. So what I would get as output here would be a subset of things that I, as the developer of this application, would be focused on specifically in terms of fixing. You can choose whether you want to fail a build or not. I don't know too many people who are just failing all their builds automatically when a vulnerability is found. At this point, but it is an option that you have if that's what you want to do. If you're a GitHub user and you like the GitHub interface, and within what GitHub has done recently, I think about 2 or 3 months ago, was they opened up the GitHub security to third parties to integrate with, and so Snyk container can work inside GitHub security as well. Again, the way it works, you push, on a push to GitHub or commit to GitHub. The code gets scanned, the container gets built, we run the Snyk container scan against it, and the output of that, while it can also go to Snyk, the more direct place that you might see it as a developer would be directly inside the GitHub security. So there's a little security tab for your repository, and you would see issues in that security tab that would be related to the Snyk scan, and that's part of the GitHub integration as well. Lots of different ways you can see these things, and the other place I talked about was scanning inside your Kubernetes cluster. Again, you can do this directly on Docker Desktop. Obviously, there's a Kubernetes integration in Docker Desktop. You can turn that on, and you can scan this. This is available to Snyk paying customers, so it's not available in Snyk for free, and it's not available in Docker Desktop as is. But if you go down the route of looking at Snyk and you become a Snyk customer, this is something you can do. But generally speaking, it's not just used in Docker Desktop, it's used more often in the production cluster. So you know what's really running in production, and make sure that that thing that's running in production is scanned, and that if there's a new high-risk vulnerability tomorrow, you catch it as quickly as possible and deal with it. It also adds in more prioritization details. So beyond just the severity of the vulnerability, knowing that this is running in Kubernetes, knowing what some of the configuration for the pod is in Kubernetes, that helps to affect this prioritization score as well. And then Snyk also has a product that can scan the actual configuration itself. So if you wanted to look at the deployment for your application and make sure you are deploying it in a secure way, you can do that with Snyk too. And that would help, if you're running this as root, or you're running this as a privileged container, it doesn't need to be, or you've got storage set up incorrectly, or all kinds of those configuration issues. You can discover those with Snyk too. So real quick, I'll show you some of those things. So I've got the Snyk application running in my Kubernetes cluster. This is right here on my Docker desktop. So this one actually is running local. And you can see in this integration what it's showing me. So again, the vulnerability scan is no different. The exact same vulnerabilities exist in this application because it's the exact same container running on my desktop. What we do get that's a little bit different is this information about how it's configured and running on my desktop. So I don't have CPU or memory limits set up in this application. It could be running as root. I haven't dropped any capabilities. All those kinds of things are poor practices from a configuration standpoint. And they change the priority score of these vulnerabilities. So it's the same vulnerability, but because it's in a container that's running in the cluster, and because that pod is not set up in a very secure fashion, that's going to bump up the priority score. So all of those things become important. Of course, this is going to be monitored. So if there's a new new bad vulnerability tomorrow, I'll get an alert on that as well. And so lots of good things that come from scanning that in the cluster. And the last thing I'll show you here real quick is, if you wanted to fix that configuration and get a better configuration overall for your container, you can do that as well. Let's see here. Right, so here I've integrated, see the little GitHub icon. You can integrate with a number of source code repos. GitHub is popular, of course, but GitLab, Bitbucket, a number of others will work. Just like we showed you this image that's integrated from Docker Hub. If you have ECR, ACR, or something else as your repository, as your registry, you can integrate Snyk with those and scan them there too. But here I've integrated with GitHub, and I have my deployment file for that. So if I wanted to fix those issues that we talked about with the deployment, I can do that with Snyk as well, right? So lots of good things you can do when you integrate Snyk and Docker together and solve, for a lot of these security issues that go within the container, is also with how that container is configured, in particular how it's going to run in Kubernetes, if that's what you ultimately do. All right, so I hope that gave you a good high-level overview. If there are any other questions, or any questions, I guess I should say, please do type them into the Q&A panel. I'll be happy to answer those. You can, if you want to get started with this, you can. As I said, all of the things that you saw today, with the exception of the Kubernetes scanning, you can do for free. So if you get Docker Desktop or have Docker Desktop today, as long as you have the latest versions, you'll have Snyk in there. You can do the Docker scans. If you have the Docker Hub scanning, if you want to do that, that does require a pro or team account, so that does require a paid service. But you can also use the Snyk tools for free as well. So if you want to try out the Kubernetes configuration scanning, or you want to try out integrating with an ECR and ACR, if you have those, you can do that with Snyk, and that's all free to do to get started. So if you want to see more, if you have questions about your particular environment and want to know if and how we can integrate with it, we'd love to have you set up an individual demo as well. But if there are any questions, I'd be happy to answer those. Anthony, any in the queue?
Nope, Jim, all is quiet in the queue.
Okey-doke. All right. Well, we will wrap up today. As I said at the start, I really do appreciate you spending your time with us. If you do have other questions that come up, you're more than welcome to reach out to us. You can reach out to us through the Snyk community. If you have questions about the Docker integration in particular, or you have feedback, the Docker roadmap is public. You can find that in GitHub under Docker's account. Their roadmap is public, and you can post comments and questions in there as well. And you can find us on Twitter or I'm just Jim Armstrong. Jim Armstrong at Snyk.io. Would love to hear from you. But again, thanks everybody, and have a great rest of your day.